Hi, welcome to mathematics. In this video, we want to solve for m in m raised to the power 5 plus m raised to the power 4 plus 1 equals 0. That's a solution. I have m raised to the power 5 plus m raised to the power 4 plus 1 equals 0. So from here, we can transform this to be m raised to the power 5 plus m raised to the power 4 plus m raised to the power 3, then minus m raised to the power 3 plus m raised to the power 2 minus m raised to the power 2 plus m minus m plus 1 equals 0. So if you see, if m raised to the power 3 cancel this can cancel this, and this can have cancel this, so we have the original equation here. But let us collect them according to their like sign and the order of their power. So we'll have m raised to the power 5 plus m raised to the power 4 plus m raised to the power 3 minus m raised to the power 3 minus m square. We have minus m plus m square plus m square plus m plus 1 equals 0. So now let us take them 3 and according to their order of power, we will have m raised to the power 5 plus m raised to the power 4 plus m raised to the power 3. So we have this minus, you see minus is common here, we have minus, we have m raised to the power 3, then we have plus m raised to the power 2. If you multiply minus times plus, we have m raised to the power 2 plus m. So then for this we will have m plus m square plus m plus 1 equals 0. So we will have, you see that we have a common factor here. M raised to the power 3 is the lowest common, so and it can be factorized out. We will have m raised to the power 3. Then what will be left here? So we have m raised to the power 2. What will be left here? M plus 1 minus what is common here. So m, let's factorize m out. We have m raised to the power 2 plus m plus 1. And here we have m square plus m plus 1 equals 0. So you observe that this, they are the same. So we have, they have the same factor. So we have the one outside, we have m square. Sorry, the one here we have m square plus 1 as one factor. So then those on the other, on at the outside, we have m raised to the power 3 minus m, then plus, there is 1 here, we have plus 1 equals 0. So we will have m square plus m plus 1 equals 0, or m raised to the power 3 minus m plus 1 equals 0. So for the first equation, so we see that this is a quadratic equation. So, and it's a quadratic equation of the form ax squared plus bx plus c equals 0. So this is the first one. Let's first deal with this one, then later we'll deal with this. So we have to solve this quadratically, and to do that, let's do with using quadratic formula. But before that, we know our a equals coefficient of m is 1, our b is coefficient of, a coefficient of m squared is 1, b is coefficient of m, which is also 1, and we have c, which is constant to also be 1. So the quadratic formula is giving us m equals minus b plus or minus square root of b square minus 4ac divided by 2a. Substituting this into this formula, we have m equals minus b, so we have minus 1 plus or minus square root of b square, so that is 1 square minus 4 times a is 1 and c is 1 divided by 2 times 1. Here, we simplify, we have m equals minus 1. Really? So we have plus or minus, we have square root of 1 square, we have 1 minus 4 times 1 is 4 times 1, we have 4 divided by 2 times 1, we have 2. So we have m equals minus 1 plus or minus square root of 1 minus 4, and that is minus 3 divided by 2. Here we have m equals minus 1 plus or minus, we have square root of 3 times, then to evaluate square root of minus 1, we have this divided by 2. So, but let's recall that our I, which is iota, equals square root of minus 1. We have m equals minus 1 plus or minus square root of 3 times I divided by 2. So we have m equals minus 1 plus or minus square root of 3i divided by 2. Here we have m to be equals minus 1 divided by 2 plus or minus square root of 3 divided by 2 square root of 3i. So this is the same as having m equals minus 1 over 2 plus square root of 3i divided by 2, or minus 1 over 2 minus square root of 3i divided by 2. Remember, these are first equation, so we just need to solve. Our second equation is here, so where we have m raised to the power 3 minus m plus 1. We have also for the second equation that we have m raised to the power 3 minus m plus 1 equals 0. So for second equation, so this equation is of the form, so like when we have m raised to the power 3 plus pm plus q equals 0. So if we compare this, and this form, that means that we have our m, which is the coefficient of m, which is equals 1, and q, the constant, we have q equals 1. So we see the equation, we use the equation to obtain the root of the cubic equation that we have here. So which we are going to use m equals u plus v. So this u plus v. So this is derived from Cardano's formula and used to solve cubic equation like the one we have above here. So where our u equals cube root of q divided by 2 plus d. So the d we have here, we call it discriminant, and also v equals cube root of q divided by 2 minus square root of d. But d, this our d equals q divided by 2 square plus p divided by 3q. So let's first solve for d here. We have d equals, our q equals 1, divided by 2. Then we have square plus p. Our p equals minus 1. We have divided by 3. We have cube. So we have d to be equals 1 square we have 1. Then 2 square we have 4. Plus minus 1 cube. We have minus here. 1 divided by 27. And if you find the LCM of this, we have 108. 4 in 108, we have 27. So 27 times 1 minus 27 in 108, we have 4. And that is 4 times 1. From here, we have d equals 27 minus 4 divided by 108. We have d to be equals 27 minus 4, we have 23 divided by 108. And if you look here, we have d to be greater than 0. So we now have how to find u, but remember that said our u equals cube root of minus q divided by 2 plus square root of d. So we have u now equals cube root of minus 1 divided by 2 plus we have square root of d. D is 23 divided by 108. So we have u to be equals 3 cube root of minus 1 divided by 2. We have minus 0.5 plus, if you evaluate this, you can use calculator, you get 0.461. So we have u to be equals cube root of, if you have this, we are going to have minus 0.039. Yes. So, and if you find the cube root of this, you are going to have u to be approximate, that to be minus 0.339. So that's for u. And also for v, we have our v to be equals cube root of minus q divided by 2 minus square root of d. So we have v to be equals cube root of minus 1 over 2 minus, we have 23 divided by 108. Then we have v to be equals cube root of minus 1 divided by 2, that is minus 0.5 minus, then if you evaluate this, we are going to get 0.461. So if you subtract this, we will have v equals, cube root of, if you subtract this, you are going to get minus 0.961. And if you find the cube root of this, we will have minus 0.985. So these are value of u and v. Now we can now finally find l. So recall that we have, for this equation, we have m to be u plus v. So we have m to be our u. The value of our u we got was minus 0.339 plus the value of v we got was 0.985. So from here we have m equals minus 0.339 plus times minus, we have minus 0.985. So we have m to be approximated to, if you have this, you have minus 1.324. So therefore here, initially we got m to be equals, m equals minus 1 over 2 plus or minus square root of 3I divided by 2. So we have m1 to be equals minus 1 divided by 2 plus square root of 3I divided by 2. And m2 equals minus 1 divided by 2 minus square root of 3I divided by 2. And we can have our m3 to be equals minus 1.324. So these are final answer. These are the three that we have, the three solutions that we have. Thank you for watching. I hope you enjoyed this video. Can you like and leave a comment, and don't forget to share with your friends and network. Do also subscribe to my channel to stay updated on my next video. Bye.